Hello and welcome to this section, Infrastructure as Code Approach with Rancher to reduce the cloud provider lock-in. Let's see the talk agenda. At the beginning, we will see the context. So we would like to describe you this common situation, then proceed with the infrastructure as code tools in the Rancher landscape. Then I will leave the talk to my colleague Luca just to show you two ways of infrastructure as code approach using Rancher. The first one is Rancher RK2 cluster template, and the second one is related to the Terraform Rancher official provider. First of all, let me introduce myself. I'm Giuseppe Cozzolino. I'm an Italian pre-sales engineer at SUSE. With me there is my colleague Luca. Thanks, Luca. So, as mentioned before, let's start with this talk, starting from the context. The context that is regarding the adoption of the cloud providers in a situation that we can define common. We would like to start with specific data taken from the 2021 report from DORA's Accelerate State of DevOps. We can first of all define this context as a cloud world. A cloud world where the companies are enforcing their strategies based on the cloud adoption. And from this report, we can define that the 79% of the questioned companies decided to base their IT strategy on the cloud adoption. When we talk about cloud adoption, we talk about the adoption of both or several cloud providers, public, private, multi-cloud, so multiple cloud providers together, but also hybrid cloud solutions. So where the on-prem installation is always part of the infrastructure of the companies, but there is also the adoption of the cloud providers. And always from the mentioned report, we can also say that more than 35% of the companies, so starting from this 79, those 35% of companies decided to adopt multiple cloud providers. Here we can evict that more than 35% of these companies decided to adopt strategies based on multiple public cloud providers. So this means that there is an announcement and a huge growth that is started some years ago that regards the adoption of the cloud providers inside the companies as basis of their IT strategies. But this is also a little bit a risk. Just because when we talk about multi-cloud strategies, we also are referring to the ways how the organizations are working with the cloud providers. Each one of the several public cloud providers offer different solutions, different solution as a service. For example, here we can see that for AWS, we can have specific services managed by the AWS console or the AWS CLI. This means that every time we would like to start a new service, a new project in our company, our IT team should be skilled on the AWS services. The same approach is replicable also for the other cloud providers. This is because every one of them can offer similar services from the others, but each one of the services that is managed by the cloud provider requires specific skill set, requires specific knowledge that is related to the cloud provider. I just mentioned, for example, the CLI. We can say that AWS has its own CLI. The same is for Azure, and the same is for Google Cloud. But this means that also referring to the data that we saw before, so for the companies where the multi-cloud strategy is actual, this means that the IT should be skilled on multiple cloud provider at once. And this means also that if you would like to migrate from a single cloud provider to another, this could be a little bit tricky, just because, first of all, you need to put or you need to grow your team with specific skill set related to the new cloud provider, and also because we can also say that each one of the services that is provided by the cloud provider is related to the cloud provider itself, and we are going into a de facto lock-in, because each one of these cloud provider offer similar services to others cloud providers, but as we mentioned, the migration from one cloud provider to another is not so easy, as is not scalable, because there is a lack of knowledge between one cloud provider to another one. So these can absolutely cause specific risks, and also a huge growth of the costs. So now let's see how we can try to avoid this lock-in, and what SUSE with the Rancher can offer to simplify the multi-cloud strategies. Here we can see that we have the three cloud providers that we mentioned before: AWS, Azure, and Google Cloud. When we talk about cloud solution, but also cloud native solution, regarding, for example, the software adopted by the organizations, we can absolutely mention the container and the Kubernetes adoption. This is because, thanks to this cloud native solution, we have the possibility to abstract the layer that is between the software and the infrastructure. We can create application, or start using application that are based on container and on Kubernetes, without thinking about the infrastructure that we have on the layer below. So this can absolutely bring on the table much flexibility, max scalability, but also the possibility to create a layer of abstraction and portability between different infrastructure, in this case between different multi-cloud and different cloud providers. Thanks to SUSE, thanks to Rancher, we have the possibility to have a unique single pane of glass, a unique platform, but also a unique way to manage these Kubernetes clusters and containers, thanks to a web application that is Rancher, but also thanks to the REST API and the infrastructure as code provider provided by SUSE related to the Rancher platform. Within Rancher, we have the possibility to manage several Kubernetes clusters with different Kubernetes distribution, also using the hosted Kubernetes distribution provided by the cloud providers from the same platform, from the same console, using the web application, but also the REST API provided by SUSE and the infrastructure as code providers. So I mention a lot of times infrastructure as code, but let's see what are those infrastructure as code tools that are in the Rancher landscape, and first of all, what are the benefits that are related to the adoption of the infrastructure as code tools. So first of all, when we talk about infrastructure as code, we talk about a new standard, a new way to provide systems that are based on generic infrastructure. When we say generic infrastructure, we mean infrastructure based on cloud providers, based on on-prem, So we can, first of all, say that the infrastructure as code is a solution that allows to manage system on all the infrastructure. And related to this specific scenario, the infrastructure as code is a new standard to abstract the management of the infrastructure in a multi-cloud scenario. This because related also to the slide that we showed before, that is about the usage of Kubernetes and Rancher. Thanks to the infrastructure as code, we have the possibility to improve our scalability. First of all, because we have the possibility to automate the management of our infrastructure. We can create and define standard of declarative infrastructure and management of Kubernetes clusters within this infrastructure. Having an automation, having a declarative approach, we can also improve the documentation that is related to the infrastructure configuration, but also improve the security, because the human error in a mi- are in a minor number related to the manual configuration, because thanks to the automation we can easily create new environment. For example, we can easily adopt disaster recovery strategies, because we can create, as I mentioned before, new environment. We can recreate part of our infrastructure, and this absolutely can bring on the table two main goals. The first one is an improvement related to the speed of the management of the infrastructure, or the creation of the new components of the infrastructure, but also an important cost reduction, because thanks to the automation and thanks to declarative approach, we can also optimize the infrastructure configuration and infrastructure automation related to the management of the infrastructure itself. On the right, we can see the most common infrastructure as code tools, starting from Terraform, Ansible, but also mentioning SaltStack and Puppet. But considering that we started our discussion talking about the cloud and cloud adoption, we can also say that each one of the cloud provider is providing on its own infrastructure as code solution. For example, for AWS, we have CloudFormation, for Azure Resource Manager, and for Google Cloud Deployment Manager. This, first of all, is an important step to say that the cloud provider itself is focusing on the infrastructure as code, providing a solution to automate the infrastructure management, but also is the continuation of something that we mentioned before. Each one of these cloud provider is providing a solution also for the infrastructure as code, but these solutions are related to the cloud provider itself. So there is no way to be scalable, to create a standard, a common standard through several infrastructure, for example, through different cloud providers. And in this case, the only way to try to having a common strategy is to use an abstraction layer, an abstraction infrastructure as a code tool that allows to manage everything from a single way, from a single console, from a single pane of glass, from a single common REST APIs, adopting, by the way, the automation strategy that we mentioned, thanks to these benefits provided by the infrastructure as code solutions. So now that we set it up this common context, I would like to let Luca to show you what SUSE with Rancher can offer to get all the benefits from the infrastructure as code solution, thanks to the Rancher adoption, and as we mentioned during the agenda, thanks to infrastructure as code provider like Terraform integrating it with Rancher. Luca, the floor is yours. Thank you.
Thank you, Giuseppe. Thank you. So let's start. In this remaining part of this talk, we will show you two different approaches that we can use to use an infrastructure as code strategy to manage different Kubernetes cluster deployed on different cloud providers. The first one is related to a tool directly related to Rancher, and this tool is represented by RK2 cluster templates. The second way we will show you is related to a more general tool using one of the most common infrastructure as code standard tool, which is based on the Rancher Terraform provider. So let's start with Rancher 8K2 cluster templates. First of all, what is an RK2 cluster template? A cluster template, as we will see, is an Helm chart that includes all the information needed to provision new nodes in an infrastructure provider and install Kubernetes with the predefined configuration on top of those. What does it mean? It means that within our Rancher, we will add a new, let's say, a new provider. Okay, we will see our template in our provider cluster. Okay, and within this this view, we will create a new cluster based on the definition that we will give. We can view an example here in this repo. Okay, so what will we find in this repo? In this repo, we will find all the definitions, for example, resume here, all the definitions that we will need to create a cluster on a specific cloud provider. You see here that we have all the definitions in our regarding our cluster. So the name of the cluster within Rancher, the name of the credentials that should be used, the cloud provider itself that we will use, for example, AWS, DigitalOcean, Azure, Cloud, and so on. The Kubernetes versions that we will use within this cluster. After that, we will define all the configuration that our Kubernetes cluster we will use. For example, if we need some network configuration on our control plane, some network configuration on our worker, and so on. All the things that we usually define when we define a Kubernetes cluster within our Rancher. Okay, so let's take a look. See the repo that we will talk about. Okay, you see that within this repo we have all the Helms charts that we need. Okay, all the charts defining all the configuration needed. Okay, we will define our values. So as in every Helm chart, we will define all the variables with their values, the variables that we have in our Helm chart. After we make all the description of our Kubernetes cluster, we will import this specific template within our Rancher running instance, and after that we will create a Kubernetes cluster. What is the important point? The important point is that all the configuration of our cluster is defined within our Git repository. So if I have to make some kind of change in our standard infrastructure, in our standard Kubernetes infrastructure, I will modify our YAML within our Git repository. We will have the possibility to visualize all the differences that I made within our repository, and after that the changes can be approved by another member of my team with a, let's say, a pull request, with a pull request, and after that, the modification will be made into our infrastructure. So infrastructure as code. Everything that is related to our infrastructure is defined as code. And we will use all the nice things that we have in our Git repository to control our infrastructure. It is a really powerful tool if you think about it. So now let's go on Rancher instance that I'm running. Okay, so let's log in into our Rancher instance here. Now, from here, you see, I can, I have my local cluster, okay, local cluster, which is the cluster where Rancher is installed into. From within our apps and marketplace, I can add a new repository. Let's create a new repository into our new repository. Let's call it tree. It will be related to a Git repository, okay, and on the branch main, let's create this repository within our apps and marketplace of our local cluster. Okay, so we added this RK2 templates. Okay, now let's try to create a new cluster within Rancher. Cluster management, create. You see that here we have our new cluster template to be defined on our Git repository. You see that here we have a few configurations that we can make within our Rancher. Okay, so for example, I can use my Azure credentials, I can use my Azure infrastructure provider, and so on, and define my Kubernetes distribution. After I have defined all the configurations that I need, I can create my new cluster clicking here on install. Okay, you see that this is a really powerful tool. It is really powerful also because defining a cluster on our Azure infrastructure or on our Google infrastructure or on our AWS infrastructure is a really similar procedure, so that we can be really multi-cloud, let's say, in a really easy way. We do not have to know the details of our Azure is working. We do not need to know the details of how Google Cloud is working. We can delegate Rancher, and at the end of our procedure, we will have just our Kubernetes cluster to interact with. And we will interact with our Kubernetes cluster in the same way, even if it is hosted on Google, AWS, Azure, and so on. So a really powerful instrument. Okay. This is what was related to RK2 templates. Now, give me a minute, a couple of seconds to go back on the slide here. Okay. Now, the other tool I wanted to speak about is the Terraform Rancher provider. Okay. As you know, Terraform is a widely used tool for infrastructure as code, and Rancher offers a provider related to Terraform, and it is a really incredible popular way for automating Kubernetes cluster state. So what does it mean with state? We mean that we can create our cluster, we can modify it every update that we make in our cluster configuration will be done through our Terraform Rancher provider. You can find all the documentation related to this to our provider here. Now I will show you a really small example. Okay, so in within our rancher, um, within our rancher provider for Terraform, we will have to define first of all the API URLs. So we will need a running rancher instance on this URL. Okay. After that, we can interact with our instance and we can instruct our instance to create, for example, a downstream cluster, so a cluster configured within our range instance with a specific Kubernetes version that can be defined within Terraform, and again with this specific configuration. Okay, you see that here we have our machine config. Let's go to have a look on a different Git repository when all of our configuration is defined. You see that here we have two different files, downstream cluster AWS, downstream cluster Azure. Let's go to see what we have within our downstream cluster AWS. Within our downstream cluster AWS, we have to define all the resources that we need to create a Kubernetes cluster on AWS through Rancher. So we will have to define the credentials that we will use to interact. We will have to define how we want the machine to be configured within AWS. For example, in this case, we will use EC2 instances with a specific MEI within a specific region, within a specific security group, and so on. And after that, we can create an entity called AWS downstream cluster of type Rancher 2 cluster version 2. And within this instance of this type, we will define everything that we need to define our Kubernetes cluster. For example, you see that we will define, in this case, a Kubernetes cluster made on 3 nodes with this specific machine config related to these specific credentials. All the nodes we will have all the roles that we can give them. Okay, if we do the same thing going into our downstream cluster Azure file, we will see that the configuration related to specific Azure configuration will be different for sure, because they are two different cloud providers, but all the differences will be within this really small part of our configuration. And the configuration of our Kubernetes cluster will be really similar. You see that here we have a cluster made of 3 nodes, everyone with all the roles, and so on. So now we show you these two really powerful instruments that we can use to follow an infrastructure as code approach through Rancher, and we see that they are powerful tools, and we can easily manage our infrastructure with RKA2 cluster templates and Terraform cloud providers. Thank you.
Thank you, Luca. One thing that I would like to remember you is that those are absolutely examples, just to show you how can you abstract also the rancher management from Terraform provider. This means that you don't have only the possibility to create RKE cluster, for example, from the Rancher Terraform provider, but you can also create Kubernetes clusters using the hosted Kubernetes distribution provided by the cloud providers, but using a common language, a common structure that is provided, as Luca showed, from the Rancher official Terraform provider. So thank you for attending for this session. Thank you, Luca, for your help. Have a great day. Bye, everyone.